I think one of the biggest misconceptions is the two terms that we often hear used, AI and ML, and the fact that they are probably the same. Since many of you are working in startups, one tweet that I had read recently is, if you want to seek funding, you should be using the term AI. If you want to build your team and hire, then you should be using the term ML. So I think that is the biggest misconceptions. You can think about AI as a field, like for example, physics. ML is a series of tools that help you enable that larger goal. So if you think about AI as physics, then ML could be like Newton's laws that help you achieve something. So I think that's my take on one of the biggest misconceptions. The other is the fact that just because you have data, you can throw ML techniques at it, and there would be treasure underneath that, and you will end up discovering something that may not always be the case as well. So that kind of takes us into whether you have data that is relevant, and whether you have data that is clean and prepped that could be fed into a machine learning model, and how do you align your business goals with a particular machine learning technique, for example.
I also think that one of the misconceptions is that it has to be extremely complicated. A lot of what we do at General Mills is really simple applications of machine learning, just taking traditional analytics and putting it into production, automating, even automating things as simple as consumer segmentation that people have been doing for years and haven't maybe really thought of as machine learning. So I would say it can be simple. It doesn't always have to be a big earth-changing endeavor. Sometimes it is, but it doesn't have to be. And I would also say that having the idea that artificial intelligence is going to solve all of our problems. It can solve a lot of our problems. But I think especially in marketing, there's a human element that we can't replace with machines yet. I think eventually we'll get closer, but I think there's still some nuances that artificial intelligence can't quite account for in marketing yet.
Yeah, I think one of the biggest misconceptions I've seen is that machine learning is a catch-all solution, where people say, yeah, we've got a problem, let's just throw machine learning in it and it'll solve our problem, which sometimes it does, and it can be used quite well. But a lot of the time, what you'll find is that simpler approaches are faster, cheaper, more efficient, and can solve the problem with a similar ballpark performance that what you find from the new, shiny, brand new machine learning algorithms that you find out there.
So basically, when do you decide if you should throw the new shining feature sets at your data source, and when you should use a more simpler approach?
Usually we'll start with doing some exploratory data analysis and see, first of all, do I have the data necessary to make the machine learning worthwhile? And if yes, then I'll start kind of doing some comparison between a simpler approach and some of the newer approaches, just to see if a simpler, cheaper approach could get us the same results without having to invest as much into the machine learning itself.
So I'm going to take a completely different approach from the rest of the panel, because somebody has to do that. So my biggest issue with misconceptions of artificial intelligence is that data science, machine learning, and deep learning is the entirety of artificial intelligence. And if you think that, and you would if all you read was the hype that you would get in social media and in consumer-based journal articles, as opposed to cutting-edge research and coursework and white papers, you would be, if you thought that, you'd be dead wrong. Because that is probably the most hyped part, but it's hardly it at all. there's a book called Artificial Intelligence, The Modern Approach. It's about 3 inches thick and it's about this big. It's really good for beating your kids with if they get out of line. And it is a standard textbook in universities these days for teaching artificial intelligence, and it's written by one of the core researchers at Google, and this is one of their main thrusts. And the first couple pages into it, it comes out and says, look, this entire book is an exploration of intelligent agents. What does it mean to be an intelligent agent? Consumer-wise, just walk in the Target, go down the hallway of the vacuum cleaners and look at those ridiculously priced round vacuum cleaners. You push a button, it figures out how to actually vacuum your floor in the best way. That's an intelligent agent. It learns from its environment. So perception systems and navigation systems and reasoning systems and all these other kinds of things from game AI and swarm logic and natural language and all of its forms, all of these things are part and parcel of creating a robot that goes around your house and does intelligent things. That's in addition to the old stuff of the 60s, like constraint satisfaction and logic and search and all that kind of stuff. Those 3 areas, the data-oriented part, data science, machine learning, neural networks, you stack neural networks, you get deep neural networks. The old stuff that's been around, it's in your phone, it's in transportation systems, you don't even know it's there. And all of the stuff surrounding intelligent agents, which is really deep and really vast, that's AI. It's not just machine learning data science.
So let me just kind of extend some of the ideas that have already been shared by the panel. I want to take the conversation back to how to align machine learning with a business goal with regards to misconceptions. Often you end up believing that to achieve a particular business goal, one particular model is enough, but that is most probably not the case. It is a sequence of models that help you achieve an eventual business goal. If I want to predict if my product would be going out of stock at a particular store, I think the common approach in terms of misconception is to think about building that one model that can directly do that, as opposed to I can have a sequence of models that one model can perhaps predict what the demand would be. What is my inventory in the nearby warehouses? How much time would it take to restock? Is there any seasonality to this particular behavior? And all of these models together can eventually help me predict.